It's about wearing a suit now from Amar and turning up. So what I'd like to do is make this a little bit different. So we're going to do a 15-minute presentation, and then Eric's going to take over and give a demo, which is quite interesting because everybody tells you never do a live demo in front of an audience like this. But Eric's brave enough to do that. So just a quick introduction. Won't go through that too much. I'm the one that looks like Jeff Bridges from Iron Man. And then Eric's the technical one who's going to do the detail stuff in a second. But we're going to do a presentation on unplanned downtime, or the dream of removing unplanned downtime. So just to start with, does anyone recognise this picture? I'm pleased to say there's not many of you here that are old enough to remember it, but you recognise the picture? And what is that? Does anyone want to go for what it is? 67, right? Yes. It's 1967, Stockholm, when they decided to drive on the wrong side of the road in this country. Okay, but the interesting thing, and the reason I've brought this in is, one, it's local, but two, at 4:50 a.m. in the morning, everybody stopped driving. And for 10 minutes, they had to stop driving. Then on the radio, they announced at 5 a.m., you had to move from one side of the road to the other side of the road to drive. Now, that sounds technical enough and dangerous enough, but then you think about everything else that goes along with that. You think about these road signs. They're all facing the wrong way. You think about the white lines. You think about the traffic lights. Everything on there is the wrong way around, and you can't swap those in 10 minutes. However, they were trying to do this in Sweden for just over 11 years, and they managed to do it in 1967. And then from 67 to 69, they had reduced the accidents and deaths in Sweden. So that was the reason behind doing it. And it's transformation. And part of that is the link to us. We want to talk about transformation. Wasn't much digital transformation in those days, but it was transformation. So if we move into this current world where we have digital transformation, and I'm pleased earlier that you mentioned that it's not just IT, it's also OT, and then ET, which be the extraterrestrial, if we create humans differently. But it's all of those elements. But from the transformation piece, this is a statement that I quite liked, and it's from the Cambridge Alliance, excuse me, and it was made by a young man from Mars Drinks. And it's just a straightforward statement. It's not clever, it's not special, but it is about understanding where you are and where you want to go, and then working on how you do that and delivering on it. So that could be marginal gains, that could be the silver bullet, but generally it's small steps to get to where you need to go. So from my experience, I've spent 30 years working and running service organisations. So making sure we do the maintenance, making sure we do the break fix. And I've worked in these in the areas where they're cost centre only, which is very much just break fix, nobody really cares about it. The technician is just a man you try and hide, and he goes in, fixes the machine, gets out as quick as possible. And then through time, that's moved to this revenue centre that is a differentiator. Now all of a sudden it's earning money. And one of the strangest things for me in 2009, I was working for a company, and when the revenue for service overtook the revenue for sales, there was no service representation on the board. There was a CSO who looked after sales, and his environment was diminishing, but the revenue of service was growing, but there was nobody representing that. And now that's had a real big shift into this service as a product. So if you look at solar energy, if solar energy for your house, you very rarely buy solar panels anymore. Now you are buying the energy that comes from it. And you have a better relationship with your provider. Now that's a big change, because not only do you have a better relationship with your provider, but your provider has to keep that asset and make sure they have the information and the cost structure to make that a profit. And that's where the unplanned downtime really comes in, because the more times you send a technician, the more of that margin you're eroding. And the more time you send a technician to fix something, the more dissatisfied your customer's becoming. And it's far easier now for a customer to change environments. So these are some of the customers that we currently take on this journey from GED and ServiceMax. So just working through these, what I wanted to do was to make it a little bit more personal, is tell you a little story about one of these logos. And the easiest logo for me to tell you about is actually GE. So if we look at GE and then how they have a relationship with ServiceMax. So I'm going to stand over here so you can see that a little bit better. All right, so GE is a company decided that they had enough challenges on their own to make their company profitable. So if you work through the fact that they are launching a plane every 2 seconds, and every one of those engines gives 1 terabyte of data back, they have actually now 30% of the world's electricity, no longer 25. And then they have 3,000 lives per day that they're affecting through their medical health, amongst other areas. Now, as you can appreciate, unplanned downtime is very important in those areas. I'll be flying home from Stockholm to London tonight. I will be very upset if my engines don't work halfway across. Okay, so I don't want any unplanned downtime. If you think about the effect on lives per day, right, it's severe. If the machine isn't working, someone can't get their treatment. So that's a direct impact onto someone. So it's very important to make sure that we can reduce the unplanned downtime as much as possible. But for GE, it's also really important. Over 70% of their profits come from service. And currently, I believe GE is the 14th most profitable company in the world. So this is a big thing for them. So they use ServiceMax. So ServiceMax used to be a provider of a software system for them to manage their 23,000 plus technicians that worked on ServiceMax. And well, you can see the other areas there. But that wasn't really enough for them because they wanted to move into this unplanned area. So working through that, everybody knows this PF curve. We discussed it today in various formats. But the last thing they wanted to do was to be at that end where the equipment fails. So they wanted to move back up here. So to do that, they took data from the equipment all the way along. But in the old school, we would always do a visual inspection. All right, so we'd check, the operators would tell us, it's vibrating, I don't know what's wrong with it. Okay, and then we would send a technician. It's still there. Okay, then we would have instruments to tell us. We would go for conditioning monitoring. But what we really want is the predictive. How do we get to the predictive and why do we get to predictive? Well, the reason we go to predictive is you can see the statements from the big data analytics on the right, but as a visual, you can see the cost to repair goes up hugely as you get towards the end of that. Now, a lot of people just think about the cost to repair, and that's quite a standard diagram, but we also think about the cost to the customer or the customer's customer or the output of the product. So again, think about the 3,000 lives. It's one thing that I have to send my technician out, and it's cost me 4, 5, 6 times more, but there's a cost to the actual patient that would have been seen on that machine. So there's a huge impact there that we need to focus on for that outcome of our customer's customer. So to do that, we've already got the data, the information coming from the connected equipment. But what we've done at GE is we created this asset performance management tool. And then the asset performance management tool, which is the one I'm going to talk about next, then leads into the ServiceMax tool, which I'm going to talk about afterwards, very briefly. And then Eric's going to give you a lovely demonstration of it. So to get the information, we've accelerated the learnings by using the digital twin. Okay, so we just use that simply, that if it gives you a warning, we understand what that is in advance. So very simply, you have a straightforward sensor tag that gives you your thresholds. Okay. Now, without any information, we've got the top line as the alarm threshold. But what we do through the digital twin is we take an expected value, and then we use that as a dynamic band, and then you can see where the warning's coming. So we can get that ahead of time, so we can accelerate our learning, and then accelerate the benefit we can give back to that machine. So we have 800,000 digital twins. I've got to be honest, I don't know how you can have 800,000 digital twins, because that's a lot of things. Okay, but we have 800,000 digital twins, and they're not all GE. They apply to all of these products. So that gives us the opportunity that we talked about earlier, is we see an alarm, which is an early warning, but we can also work out that that becomes a false alarm, because one alarm on its own is not necessarily good enough to create a proper warning. So we can use that outside of the dynamic bands to find out different areas that create more alarms. When those alarms come through, they create, or the monitoring station can review those. This is an example of a monitoring station which does the US power, and they look after 80% of the US power at GE, and they monitor, and it's not just GE products they monitor all of the products in that range. And then that gives us this little tool there we have with asset performance management, where we can start with the analytics and the action that go around. If that needs to cause operations, if that needs to cause some remedial work, it will kick that off. And then that comes back to the risk and then the strategy. So it's continually changing. Okay, a lot of people say practice makes perfect. I'd say that may work in sport, but in business, practice generally makes permanent. If you keep practicing the same thing, you get the same results. So we need to be able to challenge this all the time to make sure that we are getting the right results and continually improving. Okay, so we add that together, and that's the APM. But then we have to move to the end. So how do we deliver that if there is actually something to do, if there is a maintenance to do, or if there is a physical failure or an alarm? That's where we introduce the digital worker. And the digital worker is part of the ServiceMax tool that helps manage and maintain what we do with a technician. It gives them a fully mobile device. It works on and offline, and it goes through things. I'll briefly show you. You can have a better look at the pod outside, but checklists so you can get health and safety, regulatory aspects of the job to make sure the technician follows those rules all the way through the work. The calendars, the scheduling, making sure you schedule the right technician with the right skill sets, with the right qualifications to be able to go and provide that work and provide a first-time fix, and so on. But the one I do want to focus on here is the engineer senses. Okay, you've got machine senses, which is great, but the engineer has all of those additional senses to add to that. He can touch, feel, see, report back, quantify that you're getting the right information from all of those sensors and data. Okay, so that moves in. So as the operations and maintenance comes through, you can then start to schedule with intelligence, schedule the right technician. That technician can do the work that they're supposed to do because they have the right skill sets, the right parts, everything else that goes with it, you can schedule up front. That comes back to a work called a debrief. So that's the bit where the technician does all of those reportings that you've seen in the other presentations, where he or she can put in specific detail and data to confirm what's happened, what you've done, and what the sensors were driving, including photos or anything else that you need. And then that goes back live, real time, to either the ERP systems, creating dashboards, or to the operations and maintenance. Now, for the first time, one of the huge benefits that we have at GE and ServiceMax, because GE bought ServiceMax, acquired ServiceMax nearly 2 years ago, year and a half ago, they've decided that it isn't good enough having these two products. You can have these two products, you can buy one in isolation or the other one in isolation and reap the benefits. But what they've managed to do is now integrate these two together seamlessly. So you can go and have these complete figure of eight, eternal wheel, however you want to call it, relationship between these products. And they can help you keep learning to get to that desired outcome, which is unplanned maintenance. Now, in heavy industry, apparently, an hour's unplanned downtime is equivalent to $264,000, according to the industrial analytics. $264,000 for an hour. So you can see the benefits of removing that unplanned downtime. Now, normally, I would go through some screenshots to show you a little bit about the product. But what I'm going to do is I'm going to hand you over to Eric, who's going to give you a little demonstration of the product.
So to set the stage for this demonstration that we're going to do, I'm first going to show you a very brief video of how we identify an alert in our asset performance management system, which I probably will refer to as APM, even though I'm not supposed to. The essence why I'm going to show you this as a video is that it's a real-time event, and I guess you don't want to wait around for one to happen. But I'll go ahead and start this off. So basically what we can see right now is what we call a smart signal alert. And a smart signal alert, it's basically what we've been talking about all day. It's how we see that we have an issue with one of our pumping systems. And we now would want to learn more about this specific issue. So when we dig deeper into the analysis view, we're going to see our expected values in green compared to our observed values. So basically the digital twin is the green piece. And what we're observing here is that we see an increase in RPMs, we see surge in temperature, and we see loss in efficiency. So we realize that there's an actual issue with this pump that's going to need someone to actually have a look at it. So what we now are going to do is that we're going to go into the case where we basically store our information about this particular event, and we're going into a related action towards this alert that we're seeing. And we can see that right now the recommendation is to continue to monitor this specific instance. But once we drill down a little bit further here, we are going to see here that similar alerts in the past has resulted in unplanned downtime. So we want to change our recommendation. And basically what we're going to do is that we're going to give a recommendation to have a look at the rotating parts, and we're also going to have a look at the power supply, because these are typical issues that have caused this in the past. And we're going to schedule this to be resolved within a week from now. And now we're actually going to go ahead and create the actual work order for a technician to go on site and work on this. So this is where the live piece comes in. So I'm quickly now just flipping over to our ServiceMax tool. Okay, so basically now here in ServiceMax, we can see that there's a number of pending actions that we have. And these pending actions are actually work orders for technicians to go on site. And there's a number of different initiation sources here that we can see, where one of them is a customer portal, meaning that there's a customer that has reported an issue, which is not where we want to be. We want to understand the issues before a customer sees the issue occurring. And then we have something that comes from a planned maintenance, basically coming from a plan in the asset performance management system. And then we have predictions based on what we've seen in APM. So what we're going to look at is that we're going to look at this prediction that we looked at for the specific pumping system, which is out in a fictionary customer called Kista Technology. So we're going to drill down into the specific work order, and we're going to see how we're engaging the actual technicians to actually take part in the data that we rendered out of APM. So we can see here that the type of this order is a connected service order, meaning that we have triggered this based on data that we recorded. And we can see that the status of the order is open, the customer is not yet down, and the initial failure code that we're seeing here is an overheating problem. And most importantly, the status of this order is that it's new, it's not yet dispatched. So when I scroll down on this order, I can see here that I have the same type of information that was given to me in APM, but in a more digestible format. So basically, I can see here an RPM increase and an efficiency loss. Major heat generation could be related to the power supply based on the failure code. So what we want to do now is that we want to find a technician to actually go out and help us with this job. So basically, what I'm going to do is that I'm going to open up our dispatching tool. And the dispatching tool, we call it Dispatch Console, is basically a way to match technicians with work. So what we are going to see now is that we have the work that needs to be dispatched and our technician team. So on top here, we can see that we have this order, which is the technology, and we need someone that has advanced calibration skills in order to be able to solve this. So basically what we're going to do is that we're going to ask ServiceMax to find us a technician for this job. So I'm going to invoke an action which is called find technician, which basically says that, give me a technician that has some available calendar time and is reasonably close to where the job is and has the right skills. So we got a couple of hits. We have Stacy Offerlin up in Uppsala. We have Scott Techman just here in central Stockholm. And we have Michael Smith out in Nacka. So basically, we can see here that this is the work that we need to match them with. So now I'm going to have a look at their calendars. So basically, I can see here that Michael Smith, he has some available calendar time right now. So why don't we go ahead and schedule this job with him? So I'll just casually drag and drop it into his calendar. And basically now the system says that, okay, on average, this takes 2 hours for a technician to perform this task. So let's schedule him 2 hours, and with the current traffic situation, we estimate about 30 minutes drive time. So basically, we're going to go ahead and save this job. And what happens at this point is that the technician gets notified. So the technician, he's obviously on the road because he's a technician, so he's going to use his mobile device. So I'm going to flip over to the technician's mobile device. And basically, he's going to see here that in his calendar, he now has a new job added. So basically, he needs to be out at Kista Technology at 12 o'clock today. So now as a technician, I'm cautious because there might not be, internet connectivity where I'm going. So I'm going to make sure that I'm going to store all of the information that I'm going to need to complete my work on my mobile device. So basically, I'm going to make sure that I sync my data. And also since I'm on the road all of the time, I need to know like where am I going and where am I actually right now. So he could plot where he's going on a map to basically make sure that he will make it there in time. And now the technician is going to drill into his specific order. And on the order here that the technician looks at, he's going to be able to find all of the same information as the dispatcher could from inside the base. And basically he can see here that, okay, we have an RPM increase and an efficiency loss. And most importantly, we can see which system is affected. Because this is very, very key for a lot of our customers, because they don't really even know what type of equipment they have on site. They might just get a notification without knowing what they're supposed to service. So when the technician comes on site, of course he will make sure to log his arrival on site to make sure that the customer is notified that he's there, he's performing his work. As Kieran mentioned, he probably is going to go through some site safety checklists, and he's going to validate his accreditations to go online. But what he also is going to do is that he's going to drill into the specific assets that he's servicing. So he's going to open up the service bill of material for this specific part, or for this specific machine, to see actually, okay, what's installed at this site. Okay, I see that it's this system, and I see that I have a number of subsystems that are also related to this asset. So at this point, I could figure out everything about what's installed, when it was installed, and what the status is of every single component. So now that have figured out what I'm going to do, I can start troubleshooting my problems. And I'm not going to go through that in detail, but basically you could use your troubleshooting manuals, or you could just connect your device to the device to make sure that you run diagnostics, etc. And now let's say that he has found the root cause of his issue. He might want to initiate a swap of a part to make sure that his service bill of material is intact. And basically he wants to tell, what asset am I replacing and what am I putting in new. So he's going to look through his trunk stock, and he's going to find that I'm going to take this serialized spare and put instead, and basically save this action to update the service bill of material, reset the statistics for that specific device, and he's also going to, of course, send an RMA to get the product back to base. So now that he's done with his part swap and he's confident that the machine is back online, we get to the most important part of closing the loop between ServiceMax and APM. So what we want to do is that we want to complete the job by debriefing the specific job once we come up with a solution. So basically what we're going to do is that we're going to use the description that we were given from APM to begin with, and then we're going to give some feedback on what we actually did to resolve this issue, so that we can recommend a prescriptive action against this the next time this alert is generated, and in that case be more predictive in the way that we do service. Maybe we could schedule this type of maintenance with the previous maintenance in order to be more efficient. So we thought in the beginning that the battery unit might have been a problem. It ended up it wasn't. It was the power supply that was the problem. The problem was that, yes, it was overheating, so we're going to be fine with that. And it was not because of a power surge. It was actually because the auxiliary adapter was not changed in due time. And based on doing these actions and saving this, the technician is going to feed back all of the information that APM needs to improve for the next time this alert is scheduled. So once the technician is done on site, he's of course generating a report of everything that is done and making sure that the customer signs off on the work that's been performed, so that we can start our invoicing process if something like that exists, to reduce the days of sales that we have outstanding with the customer. And basically at this point, we have closed the loop between finding an alert, resolving the issue, and actually feeding back the information for the algorithm to improve. So thank you, and back to you, Kieran.
Thanks very much, Eric. So I guess with the 3 minutes left before lunch, we can have a look. So examples of customers that have done this. So Electa, with their 78% connectivity, they've managed a 40% increase in first-time fixes, which is impressive
Thank you
for their
very much.
environment.